Thanks everybody for showing up and trying to help us launch this year. It's been a tremendous effort that I learned about when I joined Chrome, and it's been very exciting to work on it. So I welcome questions at any point in time. Don't wait till the very end. We'd rather answer them as we go and make sure that they're relevant in the context. So we're going to cover it basically in two parts. What are the parts that we've changed in Chromium and how we are morphing it, and then what is that other teams need to do in order to build off of what we've changed. So the very first part, the key part, is that frames are now the unit of interaction with web content. It's no longer a page. And you can think of a page in the simplest example as one instance of a frame, and then you can have iframes be subframes in that. So what we've done is we've introduced in the browser process a class called FrameTreeNode, and what it does is it tracks literally the all the frames that are present on a web page, and since they're in a tree formation, we've called it FrameTreeNodes. Going forward, the browser process is going to be the authoritative place where the frame tree and all the frames are known, because each renderer has limited view now that we've split separate origins. They have a limited view of only the frames that they know about, plus any placeholders for other origins that we've rendered in a different process. So each renderer will have a cached copy, and everything would be in the browser. Now, render view is going away. We've moved a huge chunk of its code over to render frame. All of navigation is moved over. A lot of the observer interfaces have been moved over. Mainly what's left over to tackle is some rendering input events functionality. But hopefully this quarter, at most Q2 of this year, render view should more or less disappear from the code base. And what's also happening right now is the browser process is using frames to track navigation, to handle the process model, to know when to swap and do cross-process navigations. And basically, within the content module, all of the core pieces have migrated to use frame as the object instead of render view as the representation of a full page. So just to give you a more visual of what it looks like, if we take that visible page up at the top, where we have A1 is basically a document on A.com, A2 is another document on A.com, and B3 is the frame that hosts content from B.com. The browser process structure starts off as we had before, web contents, which is the representation of a tab or a page. And then it used to have different classes underneath it, but now as a first layer, we have a frame tree, which is just a utility class to help us manage all the frames in the tree. It doesn't have as much functionality, but it's mainly just to maintain the structure. The key part is those frame tree nodes, which are the stable representation of a frame on a page, and they have unique IDs that are monotonically increasing in the browser process. So no two frames would ever have the same ID, unlike what we have today is with render view. The uniqueness factor is determined by a routing ID and a process ID. So we're moving over to frame tree nodes that have unique browser side ID. And these are the stable objects that you can think of when it comes to a frame, because in the world of cross-process navigations, we have a render frame host that is bound to one process. And when we do cross-process navigation, we create a new render frame host in another process, and then we swap them at some point in time. What stays constant throughout that lifetime is the frame tree node. So in order to help us manage the complexity of cross-site navigation, we have a render frame host manager object. It used to be render view host manager, which is literally the state machine of maintaining the logic of doing cross-process navigation and starting up processes, cleaning up all processes and objects. And then we have now, instead of having a render view host for the entire page, now each frame tree node would have a current render frame host. And there is one for each frame, and the color scheme basically represents the frames in A run in one process, the frame in B runs in a separate process. Now, in order for us to support cross-origin JavaScript interactions, we need to somehow in each process, render process have a full representation of the frame tree. So when you go in JavaScript and say window.frames at 1 dot something, we should be able to satisfy those requests. So each render process would have its own copy of the frame tree. And instead of having actual frames in the cases where the real document lives in a separate process, we're going to have a proxy object that basically is just a stub that helps us route messages. And those are called render frame proxy and its host version render frame proxy host on the browser side. So as we add more frames to the picture and more of them are cross-site, these objects basically multiply quite a bit. So any questions so far on how things look? Good. The other interesting part is when it comes to rendering endpoint events, things are a little bit different. We're not going to have a render widget host, which is the unit of code that deals with rendering an input event. We're not going to have one per frame, mainly because of overhead and also makes our lives simpler. What's going to happen is there's going to be one render widget host per what we call frame group. And the way we define frame group is every time you have a frame whose parent is in a separate process. So in this picture, A is the top level frame, which has 2 frames to B. Now, the interesting part is, if you notice those 2B, they have different color. The reason is they actually have different render widget hosts because both of these frames have its parent in a separate process, which is different in the case of the B's in yellow, where the 2 B's are in the same process and the second one has the same parent in the same process. So basically you can think of, in this picture, instead of having 5 render widget hosts, we're only going to have 4, and these are the gray areas that you can see. And then this is for helping us do rendering. When it comes to input events, our current implementation is suboptimal. We send input events to the top level frame and then we forward it along the frame hierarchy to where it needs to be. But we're planning forward to basically do input event routing from the browser process directly to the frame that is supposed to receive it. For keyboard events, we need just a little bit of work to get focus controller moved over to the browser process so we know which frame is in focus, we can send keyboard events. And for mouse and touch, we need to work with the surfaces team to make sure that we integrate the code and we know which surface belongs to which process, we can send the input events directly there. Go ahead, questions? Correct. So the question was, what would the blink rendering tree or frame tree look like? Are you asking for this specific example or the one before? So in this specific example, you can see there will be 3 processes, one for A, one for B, and one for C. In the process of A, you're going to have a top-level render frame in the content layer. Its corresponding object, which Daniel would cover in a lot more detail, it's called local frame. And then you're going to have remote frames for everything else as the proxy stubs. And then in the process for B, you're going to have a remote frame or a proxy at the very top, and you're going to have 3 local frames with 1 more proxy for C. And then you can extrapolate for C, is going to be 1 local frame with everything else being proxies. And B would have 2 render widgets attached to those top level Bs. And A and C process will have 1 render widget per process. And Daniel is going to cover extensively how the blink tree would look like and what the corresponding objects in that layer are. So we're going to also have quite a bit of architecture cleanup, which we've inherited from the past. For example, we're going to get rid of render view. And one of the things that we're super excited about is we have that notion of swapped out. How many of you have actually seen swapped out? 1, 2, wow, a lot of people. You're not supposed to see it. It is not something that should be visible outside of content to begin with, and it's also an implementation detail. But because of how code was structured, we couldn't just get rid of render view. until recently. So we made render view have a specific state called swapped out, which represented that proxy mode where it is not really an object that we need, but it's just a proxy so we can route events and messages up to the browser process. Now, at this point, or at some point very, very soon, we're going to be able to get rid of this, and it's going to be replaced by the render frame proxy object. And that proxy will be a very much lightweight object that all it does is just route messages to the browser process. And the other interesting part is that in Blink, the frame tree maintenance was done at the Blink layer. Now it's moved a layer up at the web layer, and it's basically the embedder's responsibility to maintain the frame tree relationship, which means that Chromium is now the layer which manages what a page looks like. And we can simplify Blink to be basically a frame server saying, give me a frame, here's a document, render it in that frame, give me the output of it, and I'll manage how these fit together in terms of compositing on the screen or how the relationship between child-parent in the frame tree happens. So basically, Blink becomes much simpler. And there have been also interesting ideas as removing provisional load and just making frames be per document and not survive, but these are very much further in the future plans. But overall, the key point is a lot of cleanup from code that was suboptimal will be removed. So I'll give it over to Alex to talk about how we're going to replicate properties of frames in that distributed world.
Thanks, Nazcal, and I'm Alex. I joined the team a few months ago, so don't be surprised if you don't know me. So as Nazcal mentioned, the frame tree is replicated in each process, with render frame proxies being used as placeholders for frames that are rendered in a different process. So in this example, we have a page where site A embeds 2 frames for sites B and C, which results in 3 rendered processes. And for example, in process A, we have a render frame for the top level frame and 2 render frame proxies for B and C. Now, sometimes frame properties need to be accessible in a different process. So for example, in process B, if the frame B decides to navigate frame C, that involves a security check where you need to know the origins of both A and C to decide whether that navigation is actually legitimate. And that's a problem because E and C are only placeholders in process B. So to handle cases like this, we have a structure called frame replication state, which is copied to all instances of a frame, whether it's a real frame or a placeholder. The master copy of this lives on frame tree nodes in the browser process. And currently, this includes the security origin, the iframe sandbox flags, and the window name property. The first two, the origin and the sandbox flags, are used to initialize Blink security contexts. And these are used for security checks involving mixed content, navigation, post message, things like that. Daniel's actually going to cover security contexts in a lot more detail in the Blink talk. And window name we have to replicate because a frame can decide to navigate a particular frame by name or just read off the name attribute that was set off by its parent in the iframe tag. Now, one other thing to mention here is that we want to be careful about information we replicate. So if you guys decide to use this mechanism for your feature, it's probably best to talk to us first. Using it for security checks that I mentioned, something like this is probably fine. But for example, we don't want to replicate the full URL for frames because that could be an information leak where, say, if the process B is compromised, B will get to learn the full URLs of A and C, and we don't want that to happen. Yes? Okay.
So let's say
Yeah, so question is basically how do we keep the window name in sync so that the latest copy is visible when, for example, B tries to navigate frame C? So that's a good question, and that's something we definitely need to take care of. Window name can be assigned dynamically, and that assignment should go and update that property in all the processes so that the latest copy is visible. I think the correct behavior here is to navigate based on the latest window name, and the old one stops being valid as it's assigned. So there is a problem here where time to check to time of use problems may come up. Daniel's going to talk more about that actually. It's inherent because we can't synchronize perfectly across origins. These things are asynchronous by nature. So, but in general, yes, we will need to deal with these dynamic assignments. Currently, the replication is not handling that, but I'm working on that right now, and it should be available in a couple of weeks. And actually, yeah. Async APCs. Yeah.
Essentially, each renderer is going to have some view of the world, and its view may be slightly stale, but because the frames it's interacting with are cross-origin, it doesn't have direct knowledge of them anyway. So if something changed there, yes, it may be interacting with something that isn't exactly up to date with the other renderer process, but that's okay. And then the browser process has a consistent view based on when it receives events from each renderer.
And with that, Nasco can tell you more about how you guys need to update your features.
Okay, so these are the changes we've made to Chrome, or at least the overview of them. And let's talk briefly about how you need to go ahead and build on our platform. Basically, the first thing is move over all the render view and render view host interactions to be using either render frame host or web contents. So going forward, you can think of web contents represents on the browser side everything that is a page level. So our page level concept is web contents. Our per frame concept is render frame host. So if you wanted to say, okay, focus this frame, you need to use render frame host in order to focus it. But if you wanted to say, you know what, just make a copy of the clipboard or copy whatever selection is in the clipboard, you should just target web contents and it will actually know what the state is. So if you don't care, if you just say, hey, I want to copy this current selection of this tab, you go to web contents. If you want to do something that is per frame, you go to render frame host. And then when it comes to actually receiving events, we have observer interfaces. Render frame observer is the interface to use in the render process. That is for basically every frame that we create, you can register and become a render frame observer. All events would come out of there. There will be for the time being, there's no plan to have a page level observer in the render process itself, mainly because it's only rendering or only has documents from part of the entire document. The entire page. The entire page lives more or less in the browser process. So we have per frame observers in the render process, and then we have full page observer on the browser side. Also, you need to move code basically to be into one-to-one relationship with frames. When it comes to observers and knowing when frames are being created or removed so you can actually know about state, there's two major or two big sets of functionalities or patterns that people use. One is we want to have a extension of the content layer. Let's say you're implementing something in Chrome layer where you want an object that lives in a render process and an object that lives in the browser process. They need to communicate to each other. Then you would like to use the render frame created and render frame deleted notifications. Those are fired off on the browser side when the renderer process frame is getting created or deleted. And just to make a note, because it's a little bit subtle, is if the process is crashing or crashes, the render frame deleted message would be fired off so your component knows that, hey, I no longer have my IPC counterpart in the render process alive. When I get another render frame created, is when I need to recreate my render side component. So you can use render frame created and deleted to basically say, I need to initialize my components for this instance of a frame, send an IPC down to the renderer, create its render side part, and then manage it from the browser side. You can use the render frame host send method to send IPCs down to the renderer, and the render frame equivalent to send messages up to the browser. And when it comes to dispatching messages on the browser side, you can register for all message received as Web Contents Observer, and using the IPC message forward macro makes life a lot easier. And just to show you some code to illustrate the point is, you can look at the media CL that we linked off of the previous slide. This is code just literally copied from there, where you have the media web content observer on message received. It registered at every render frame that's being created its own browser media player manager. And when the message arrives, it looks up the manager associated with that render frame host. And then, just as any IPC handler, just says, forward this message, which is enter full screen, to the player manager that we just looked up that corresponds to the render frame host, and call the method on it that would dispatch it. So IP message forward is almost the equivalent of having your own IPC message bug for your class, but instead of having it in your class, it's in a separate one, and you specify more or less that this pointer is player manager. So this was for tracking the render frames in the renderer. If you want, like for example, as the task manager, we pointed out as an example CL here, if you want to track the set of all current render frame hosts, you need to monitor for or subscribe to listen to render frame host changed event, which is fired every time we create a web contents, and in that case we supply as the old render frame host a null pointer because there was nothing that has changed from the past. And also on every cross-process navigation, when we're transitioning from one render frame host to a new render frame host, would actually fire off this event, will specify which render frame host we're transitioning out the old one and into the new one. One note to know is we will get a render frame created for the renderer side, most likely before you get the render frame host change, which is normal because at this current point in time, we fire off a navigation in the render frame host, and once it commits is when we fire off the render frame host changed. The corresponding opposite method is the frame deleted. This we fire every time a frame is removed from the frame tree, or when we completely destroy the web contents because the top level frame is tied to the lifetime of web contents. And you can look at that task manager CL if you want to see example usage of those methods. So now we have the render side covered, the browser side covered in terms of when things are happening, but maybe you just have a user input and just user clicks something. So you need to know, hey, what is the current state? There are two methods that we have introduced, which are helper methods. For each frame on web contents, basically you can supply a callback and we'll execute that function for every frame as we walk the frame tree. And then to make it easier and save on lots of boilerplate code, send to all frames is just a convenience function to send an IPC to every frame in the web contents. And this can actually be used to break down how we do things. So for example, in the most naive way, if we have a page from the old world and we want to support out-of-process iframes, we can say, hey, send to all frames a message that I need some state, let's say accessibility. Say, what is the accessibility, and send it to all the frames. Then all frames would report back the results, and then you can assemble all these results on the browser side together to present a full view of the page. And one note is here that frame tree node as a class is not exposed outside of content quite yet. And these two functions we've added mainly as a convenience and what we believe people would need to do. If you need anything extra that is not present there that we didn't think of, just let us know. We'll try to make it easy for everybody to work with the code base. And again, Dominic here has been working with us on accessibility to move them over and helped with a lot of these. So now that you've migrated your feature, how do you actually test this? So Alex has helped us quite a bit on testing infrastructure, so I'll let him tell us about that.
So how would you know if your CLs are breaking out-of-process iframes? Two things you should do. First, make sure you don't forget to run tests locally with the Cypher process flag. And second, we have two FYI bots currently running tests with the Cypher process flag. And they are currently green. And if you notice that they go red after a change, please reach out to us or fix the problem. Or we may ping you if you don't notice it. So we have both a Windows and the Linux bot. They are running all unit tests, all content unit tests, almost all content browser tests. We have a few issues on our end that we still need to fix for that. And we've recently enabled the majority of browser tests with about 200 tests currently disabled. And you can check if your team's test is on that list by looking at this file, chromium.fyi.json, which has the gtest filter. And currently this includes many tests for WebView and extensions, but also things like geolocation, SNACL, error pages, and yeah, things like that. So to write new tests, and we encourage you all to please contribute more out-of-process iframe tests. It's very easy to do. Just make sure you set the Cypher process flag and navigate to cross-site iframes. The easiest way to do that is to use the embedded test server that we provide to you, which makes things like getting a cross-site URL really easy with both in C++ and in HTML, as you can see in these two examples. The details of how you guys can do that are in the feature update FAQ. Please take a look at that. And also we have a lot of examples that you can follow in the Cypher process browser test. And that's pretty much it for testing. So I think at this point, we'll open it up for any questions you guys may have.
One note we forgot probably to put in for unit tests in content things, we're trying to improve the APIs. It's possible, but we're trying to make it a little bit nicer going forward. So, questions whatsoever? Go ahead. Mm-hmm. So the question is basically, if we're only using a whitelist, wouldn't that prevent us from finding bugs in other sites or things that are not hit by other sites that are not in the whitelist, and possibly any mitigations for that? So one of the things we've been toying around with is put out-of-process iframes and site isolation behind a Finch experiment and play around with deploying it to either some portion of Canary or even say enable it on all Canary instances for a day and see what happens. So yes, we are going to try to experiment as much as we can on Canary and learn from these results and trickle down to stable and beta. So basically the question is, if we make Blink a simple frame server, now does that mean that Chromium needs to manage all the relationships between same origin frames that must live in the same process anyway? And the answer is yes, Chromium would manage certain things, and yes, all same origin frames would live in the same process by definition because their communication can be synchronous. And the way that frames communicate usually is basically through their window object. And the window object basically you get by traversing the frame tree. So the frame tree relationships would be maintained by the content layer of Chromium. So it's not going to be Blink, but all of the relationship between frames would be synchronously discoverable. And from that point on, once you have a JavaScript handle to an object that you want to interact with, everything would work just fine as it is today. The main thing that's happening is the entity responsible for connecting the dots, so to say, for JavaScript is going to move to the content layer, but it's still going to be the same process. That way, we can tell, hey, window.parent is either a proxy, at which point we give you a proxy object that we can use to communicate with remote processes, or we give you a real object, and then you can interact with it synchronously. And that's one of the nice things about having this new proxy model instead of swapped out objects in the past is we can only support things that are cross-origin, and then it's going to be very clear if you get a remote frame object, only a handful of things are supported, therefore you cannot do anything synchronously with it. If you get a regular object, you can do pretty much the same interactions you've had in the past, so very little should change. Any other questions? Go ahead. So if I get the question right, is in the past we've had the routing ID and process ID pair. Now for frame tree nodes, we have globally unique IDs. Have we seen problems with using the same routing ID across different processors, or basically have bugs because of those pairs? Yes, we have. And yes, we had security bugs. And yes, it's very, very easy to get these wrong. This is one of the reasons when we decided to move to the frame tree node as a concept, which is consistent for the lifetime of a frame, regardless of which process it lives in. It should have a stable identifier. So when code is interacting with the frame, they, knowing which node it is in, they could always get the current render frame host, which can be different as we navigate around. So when you want to say, hey, I want to send a message to the frame at this node, just take the current host, get its routing ID, and send it along. Or just call the send method on that object. And that would prevent a lot of problems, hopefully.
Yeah, and at the same time, we think that this new method of routing messages directly to your render frame will give you a direct connection when you have some state associated with it, say with some privilege or a site-specific object. And when you do a cross-process navigation, we won't have any swapped out state or confusion about where that message is going. It's just that frame goes away, it's gone, and you can't send or receive messages from it anymore. So between the two, having a stable representation and then having render frames that just disappear after you navigate them cross-site should help cut down on a lot of these bugs.
So the question was, can a compromised renderer access in this new model a frame it doesn't own? That is the case today, regardless. In the future, it shouldn't be able to.
We want to make it easy for the browser process to enforce these checks. Obviously, the checks aren't there today because it's all owned by the renderer. So we're looking for good patterns to use so that it's easy for the browser process to tell when a frame has gained privileges or lost privileges. So things like the bindings that are on render view host today will become render frame host specific. So If your render frame host changes, it doesn't matter if you have the same frame 2 node ID, the new render frame host won't have those bindings. So that sort of thing we hope will become easier for the browser process to enforce. But it's definitely something we have to keep in mind.
So the question is, I'm browsing the code, I see render frame, which owns a web frame, which has a lot of stuff that doesn't make sense cross-process, or doesn't make sense to be per frame. Are you planning to clean this up? Yes, indeed. We're doing a bunch of work in Blink to, as we said, to kind of untangle the things that are making sense to be in the same process and things that are making sense to be cross-process. So you can think of the proxy would be basically the cross-origin accessible subset of functionality. And whenever something overlaps, it's going to be on both, and when it's specific, it's only going to be on one or the other. And we're splitting web frame to be web remote frame and web local frame, and that will be a lot of the detail in the Blink talk a little bit later. Oh, so the relationship between web frame and web local frame. Web frame is basically the interface that web local frame inherits. So it's going to be.
It's the common subset between the two, right?
Yes,
so both,
indeed.
Both web remote frame and web local frame will inherit from web frame. So only the things that are common to the two, which is probably most of web remote frame. Yes, so remote frames will still know about their parents, so you'll be able to walk the tree. Yeah. I also want to put a mention out that as you are browsing through the code and noticing other features that may be making these wrong assumptions, point us to them, make sure that we get in touch with those teams and get those features updated as well. We've reached out to a lot of the teams that we know are affected, and thanks to those of you who are here or watching this. But we're sure that there's more than are on our current list, and so we'll want to expand that to include, make sure that everything is working. So same if you see crashes in these states that aren't reported, go ahead and file a bug. We've got a site isolation label that you can put on the bug and help us track it. So if there aren't any other questions now, we can break now, give you guys some time back, and we can meet up again after lunch to talk about the Blink side of things. So thanks again.